Lahore is famous for its many centuries-old historical landmarks. The city will now also be known for a most modern and unique bus rapid transit system, popularly known as Metro Bus Service, a brainchild of the government of Punjab. First of its kind in Pakistan, the bus service starts from Gajju to the south of Lahore and terminates at Shahdara on Grand Trunk Road in the north, running through the heart of the city via Firozpur Road. Of its entire 27-kilometer route, 9 kilometers are elevated above the city's busiest and most congested thoroughfares, where millions of commuters travel daily. But what makes this flyover a marvel of engineering is the novelty of precasting 90-ton concrete transoms. This is a story worth narrating. Precasting of transoms being the most challenging part of the entire project, Izhar Construction was duly engaged by Zahir Khan and Brothers joint venture. The section of flyover from Muslim Town Mode to Jain Mandir is a testimonial to Izhar's expertise and experience as precasting specialists. The idea of precasting gigantic concrete transoms, including transporting them safely to and properly fixing them on bridges at actual site, was proposed by the designer and supervisory consultants NESPARC. This was necessitated to reduce construction time, achieve maximum quality concrete finish in controlled environment, and to minimize wet works at site. All of this effectively reduced interference with the normal traffic at the Lytton Road area, where an extremely congested network of existing roads haphazardly crisscross one another as the construction work went on. This is how Mr. Azhar Ali Bhatti, Director Design Izhar Construction, explains it.
इसके अंदर कंस्ट्रक्शन टाइम जो है ना वो खासा रैपिडली रिड्यूस हो जाता है, क्योंकि आपको जो कास्ट सेंसिटिव वर्क्स हैं वो सिर्फ आपको पियर की हद तक करने पड़ते हैं.
It goes without saying that a project of this nature and magnitude entailed the formulation of foolproof systems and methods with all technical details and benchmarks thoroughly planned, tested and cross-checked by relevant experts before putting them into practice. After rigorous surveys and route studies, it was decided to set up a precasting yard in a hollow core, precast, pre-stressed slabs manufacturing factory at Sundar Industrial Estate near Lahore. It meant that a total of 55 precast transoms, each weighing 90 tons, would be hauled from the factory to the actual project site through Raiwind Road, Thokar Niaz Beg, Multan Road, Chauburji Chowk, Bahawalpur Road and Kartaba Chowk, a distance of around 40 kilometers. It's true that first things should be done first, but time was also of utmost importance. So simultaneously as the precasting yard at Sundar Industrial Estate was being developed, various preparations were set in motion for relevant approvals of shop drawings, concrete mix design, all materials, calibration of various equipments and methodology for the entire precasting, transportation and fixing of transoms. In time, ZKB joint venture and Izhar Construction submitted a proposal on shop drawings as per NESPARC's requirements. 3D graphics were creatively employed to accurately visualize a masterpiece of construction that would be the first of its kind in the country. It also served the intended purpose of a structural element. In the spirit of achieving construction excellence at all costs, approvals of all relevant materials and calibration equipment were obtained from NESPARC. The entire methodology, with complete process details as per the consent of all stakeholders, was okayed by a high-level team of structural and field engineers from ZKB joint venture and NESPARC, led by Mr. Abdul Basit, Vice President Structures, NESPARC.
ट्रांसम जो आपने देखे हैं जो बनाए गए हैं वो बहुत ही अच्छे बने हैं और उनकी फिनिश भी बहुत अच्छी है और उम्मीद करते हैं कि इसी मेयार के काम मुस्तकबिल में भी होते रहेंगे.
Keeping in view the number of transoms and project delivery schedule, a total of 12 molds and beds was mutually agreed between ZKB joint venture and Izhar Construction. Beds were so made as to cast the bracket portion of transom below ground level. The mold and formwork conformed to project specifications in simulated conditions that exactly matched actual portions or columns at the project site. Guide nuts were welded, threaded steel bars of the same size erected, corrugated sheets mounted, with all bolts kept plumb and aligned as per the template mechanism. Thermopore pipe casing was used between steel bars and corrugated sheets to keep them clear during concrete pouring, and plumb and aligned with steel bars for ease in fixing at site. Similarly, replicas of the precast mold's central portion that rests on actual RCC columns were used as dummy for fixing of steel out of molds. 95% of steel fixing and embedded items was done out of mold, and only final adjustment done in place before concrete pouring. After a mold was released, the next steel cage, already completed and inspected, was shifted into it, and all templates and embedded items rechecked and set in position. A final joint inspection by Izhar Construction, ZKB joint venture and Nespath professionals was carried out as per agreed drawings and specifications before pouring of concrete was allowed. The 4 stages of concrete for each transom were no less important. Of these 2 stages, concrete in the transom base and stem were completed at the precast yard, while the remaining 2, concrete in bearing pads and in shear keys, at actual site after hoisting. Crucial to any world-class construction is the quality of materials used in concrete mix. For precast transoms, concrete was produced as per project specifications using an automatic batching plant. From the batching plant, concrete in hoppers was lifted by an overhead crane and shifted into transit mixers that in turn transported it into molds below ground level. Pouring was carried out, avoiding any excessive mechanical vibrations and drop of concrete exceeding permissible height. Continuous and homogeneous flow was maintained in the entire mold. Accumulation in one part avoided while monitoring slump and temperature throughout. When the final level was achieved for the bracket portion, the top surface level was checked by a surveyor, and masons were advised to finish the surface in required slopes and levels. After concrete in bed had set sufficiently to allow working on top, which took approximately 6 to 12 hours, forms for the transom stem part were fixed in position as final levels, plumb, and adequacy of arrangements were rechecked. Concrete in the stem part was continued in the same fashion, with verticality and alignment of formwork continuously monitored. Cylinders were cast for both stages of concrete, and strength tests after 3rd, 7th, and 28th day conducted before allowing the release of mold and final acceptance respectively. Curing with fresh water started soon after initial setting of the bracket part of transom, and formwork in the stem part removed after 12 to 24 hours as per setting of concrete status. Curing of the stem part started immediately after wrapping the entire member in Hessian cloth. 7th day compressive strength of concrete in the transom bracket part was tested before releasing. For lifting the transom, 8 hooks comprising of 32 mm grade 60 deformed steel bars were embedded in concrete down to its full depth. To forestall any failure during the lifting process, 35mm steel plates were welded with the hooks. A single transom weighed 90 tons, but owing to factors of safety and concrete mold adhesion, lifting plates were designed for an anticipated load of 120 tons. Thus, each plate could safely withstand a load of 15 tons, yet tested for 40 tons. All plates were successfully tested before releasing the transom from mold. By the grace of Almighty Allah, not a single failure or slippage was observed during the entire lifting and transportation of transoms. Once released, the mold was checked for any deformations, shape changes, or damages to welds, and properly cleaned and oiled before the next pour. A 250-ton mechanical coals crane owned by HMA was mobilized in the precasting yard for lifting the transom in truly vertical position in order to avoid any damages to the forms and mold. A trailer was specially designed and fabricated in two parts to safely transport transoms from the yard to launching site. Wooden logs were used on the bed to keep it level and square. Steel guiding pipe frames were used with heavy steel pins to keep transom in line and avoid slippage along sides. Before dispatching a transom from factory, all necessary holes, penetrations, edges, and top fixing plates were given a final inspection by the technical and store staff. Verticality and position of bolts in column were checked before, during, and after concrete. The entire area surrounding a pier where hoisting of a particular precast transom was in progress was completely cordoned off. 2 mobile hydraulic cranes of 100-ton capacity were used for hoisting and proper positioning of transom. Levels of shims and spacing of bolts were finally checked. Trailer was so positioned that both the crane operators had full view of their side of the trailer and could see the other crane also. Signalman and rigging superintendent stood at a safe distance, having direct eye-to-eye contact with each other as well as with both crane operators. Once cranes were in position, all slings and D-shackles were fixed to the designated hooks, load checked, balance kept for some time, and rested again on the trailer bed or on ground as per site conditions. Cementing epoxy grout was spread all over the pier top in level with the top of leveling shims. As soon as fixing, spreading, and leveling of grout were completed, workers got down from the pier. All was now set for the load to be lifted. As the 2 cranes did it slowly but uniformly, both were closely monitored for their synchronized movement until the load reached its highest elevation and then brought to the top of bolts. Alignment of all 4 sides and 4 corners, matching the grooves of columns with the grooves of transom, was ensured. When the signalman and rigging superintendent felt sure that all bolts were within the respective sheath openings, a lowering signal was given to both cranes for lowering the load. With the load released, a temporary 15mm steel template was fixed on the transom top to bring all the bolts in their true positions. Non-shrink grout was filled until a top level was achieved to the desired bottom level of the top plate. With grout set and bolts sufficiently restrained, temporary guide template was removed and a 25 mm top plate placed in position. Nuts were tightened and tack welded to avoid any slippage. Top plate was filled with a second layer of non-shrink grout up to the transom's concrete top. Area around the transom was now cleared for further works. Bearing pads were cast in place as per required levels of the base of precast girders and neoprene bearing pads before hoisting. Shear keys concrete was done after launching the girder. Further construction was carried out in the same fashion as for the cast in situ transom.
पाकिस्तान में पहली दफ़ा ट्रांसम प्रीकास्ट की गई है, तो ये बड़ा क्रेडिट जाता है ना सिर्फ नेस्पा के डिज़ाइनर्स को, बल्कि जो जिन लोगों ने कंस्ट्रक्शन की.
The citizens of Lahore have finally got a much-awaited public transport at par with the most well-known metropolises of the world. But the story of this landmark would not have been complete without mentioning the dream come true, precast giant transoms on which literally rested the entire project. A project that will remain for generations to come, a living tribute to the ingenuity and expertise of a dedicated team of designers, architects, builders and contractors, of which Izhar Construction has been a proud key player.